Welcome to TissueGnostics. We enable precision medicine through our TissueFAXS Cytometry platform. My name is Rupert Ecker. I'm the Chief Executive Officer, and it's my pleasure to introduce you to TissueGnostics, our products and applications. You will probably be familiar with flow cytometry, also called FAXS, which is a technology that has been available for decades. When you go to Public Medline and search for FAXS or flow cytometry, you literally get thousands of papers that have been published over the decades using this technology. It offers a phenotypic and functional analysis of cells that have been stained with antibodies conjugated to fluorochromes. A major limitation of this technology, however, is that it can only be applied to cells in suspension. In order to analyze tissue sections and cells in tissue sections, we need to apply image cytometry. It is the same idea than we have in flow cytometry, and it offers also a phenotypic and functional analysis of cells, but here the cells are on slides in tissue sections which are on slides or in cell culture monolayers. These samples get scanned, and then we have the cells in images which can be analyzed by means of image analysis or image cytometry. TissueFAXS cytometry, that is image cytometry, the specific way TissueGnostics is doing it. You may have heard about what has been called the reproducibility crisis. A survey among 1,500 scientists published by Nature revealed that more than 70% of the researchers have problems in reproducing published data. An additional 20% have problems in reproducing their own data. So this clearly indicates that there is a need for action. Consequently, there has been a call for better mentorship, something universities have to take care of, a call for proper use of statistics, something each individual researcher and research lab needs to be sensitive of, and a more robust experimental design. This is where TissueGnostics can support you. Who is TissueGnostics? The company has been founded in April 2003 in the city of Vienna in Austria, the heart of Europe. Today we have international offices and subsidiaries in Romania, the United States, and Asia. Our systems and solutions today can be found in 31 countries on all continents except Antarctica. As of March 2020, we have almost 1,500 reference papers published, with dozens of papers being added every month. TissueFAXS is not a single product, it's a family. TissueGnostics is OEM partner of Carl Zeiss Germany, so the core of our hardware are high-end microscopes of Carl Zeiss. With our software, we control all the different hardware components, microscopes, scanning stage, cameras, illumination devices, and automate the entire workflow. TissueFAXS is available in different configurations, like for bright field only, that would be called TissueFAXS Histo, for fluorescence only, which is called TissueFAXS Fluo, or a combination of both, which is TissueFAXS Plus. On a scanning stage for up to 8 slides, this system can be used for scanning tissue sections on glass slides, histological samples. The immediate result of a scan in TissueFAXS, like for all other slide scanners, is a virtual slide. Here we see an example of an entire mouse leg in immunohistochemistry. Like in Google Earth, we can navigate through the sample, zoom in until we see the cellular or even subcellular details. If you want to scan also cell cultures, adherent cell cultures in well plates, TissueFAXS I will be the proper solution. I like inverted because this is based on an inverted microscope system. Again, there are TissueFAXS I Histo, I Fluo, and I Plus. Slides can also be scanned by putting the slide upside down on the scanning stage. But in extension to the upright system, here we can also scan well plates from 6 well up to 384 wells. For high throughput scanning, there is a version of TissueFAXS with a slide loader, TissueFAXS SL. And every fluorescence configuration of TissueFAXS can be equipped with a spinning disc confocal, which allows to do whole slide imaging in confocal mode. Here we see an example of a section through an entire mouse brain. In order to acquire the entire mouse brain section, 350 individual fields of view had to be acquired. The tiny rectangles that we see here are in fact high power fields of view acquired at the plan APO 20X. Each field of view consists of 4 color channels. Scanning in a single focal plane could be completed in 8.5 minutes using the 20X objective lens. Scanning the entire mouse brain section with a set stack of 21 layers, so main focal plane, 10 additional layers above, 10 additional layers below, took 1.5 hours. But this generated 29,400 images and roughly 115 gigabyte of compressed data. Again, we can now zoom in, like in Google Earth, navigate through the sample until we see the cellular or even subcellular details. The latest addition to our TissueFAXS family is TissueFAXS Spectra for multispectral imaging. In this system configuration, a liquid crystal tunable filter is used in order to acquire spectral signatures of fluorochromes. What we generate with this liquid crystal tunable filter is a LAMBDA-STACK, also called lambda cube. What is a LAMBDA-STACK? Well, you will be familiar with a set stack from the confocal. Actually, we just talked about it. In a set stack, we acquire a given region at different focal positions. Similar is with a LAMBDA-STACK, but here we acquire a given region at the same focus position but in different spectral intervals. Like we see here, Alexa 488 gets acquired around 500, 510, 520 and 530 nanometer. Alexa 555 from 510 in 10 nanometer steps up to 600 nanometer. And this is done for all the fluorochromes that are present. So we generate a fingerprinting of the entire emission, all fluorochromes combined that we have here. What we get in first place when we visualize a LAMBDA-STACK looks like this. Obviously it's not nice. The image shows severe oversaturation, spectral overlap of neighboring fluorochromes. But now comes the magic. In fact, it's not magic, it's mathematic. Spectral unmixing. By using reference spectra of individual fluorochromes, it can be computed how much of the total emission comes from fluorochrome 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We compute how much from the total emission belongs to each fluorescent channel. And what we get is this: stunning images of fluorescent stain samples with multiple markers that allow to quantify multiple fluorochromes at the same time and determine co-expression patterns. We have now seen that TissueGnostics offers microscope-based scanning systems for transmission microscopy, wide field fluorescence, spinning disk confocal, and multispectral imaging. But the most important part about TissueGnostics is our image cytometry software. Let us start with a classical example most of you will be familiar with: immunohistochemistry, IHC. We see here a colon section stained with the peroxidase DAB system. The brown marker is well known, Ki67, a proliferation marker. So the obvious question here is, how many cells are proliferating, or in other words, how many of the blue nuclei are also stained in brown? We made a survey among more than 500 scientists and asked them to estimate how many cells are positive here. And we received answers ranging from 1 to 40%. So in other words, some people think that 1% of the cells are positive, others think 40% are positive. The majority is somewhere between 10 and 20, but still this gives a wide range, and this also shows the main problem associated with visual evaluation. We always get a wide range of estimations rather than a reproducible. In our TissueFAXS Cytometry platform, we use the nuclear marker as a master channel. The algorithms identify individual nuclei, indicated with the yellow contours in this image, and then measure and quantify for each nucleus how much blue and how much brown are associated with each nucleus. This measurement is not limited to blue and brown, it can be done with any color. The results are shown in this type of scattergram. People in flow cytometry would call it a dot plot, where we see here on the x-axis the mean intensity of the hematoxylin staining, and here on the y-axis the mean intensity of the brown staining, in this case Ki67. The line here is well known from flow cytometry. It is called the cutoff. This has to be set in accordance to an isotype matched negative control, and it determines the specificity of our staining. Each individual dot that we can see here is a single cell in a tissue section. Those cells which are below the cutoff are considered the negative population, and the cells above the cutoff with a specific staining represent the positive population. And as we can see here, based on this cutoff, which has been set on an isotype matched negative control, 14.45% of the cells are positive for the marker in brown. In other words, 14.45% of the cells are Ki67 positive, and this is our proliferating population. Ki67 is a nuclear marker. So identifying the nuclei and then measuring how much brown is in each nucleus is perfectly appropriate for any nuclear marker like Ki67. But what if our molecule is not in the nucleus, not only or not at all? Then we need to use a different strategy and generate a cellular or cytoplasmic measurement mask. This is an example from skin cancer research. We see here two biopsies. One that was taken in normal skin and the second one taken after UV irradiation. On the right hand side we have our control section stained with an isotype matched control antibody that shows the specificity of our staining, unspecific binding, as well as autofluorescence can be quantified here. Normally, people will look at these samples and say, well, this sample is 1+ positive and this is 2+ positive. And then maybe your colleague comes and says, well, I would say this is 3+ positive. Rather than discussing and guessing how many pluses you assign, TissueFAXS will give you an observer-independent quantification of your tissue sections on the single-cell level. On the left-hand side, we see the result of our normal skin, and on the right-hand side, the sample after UV excitation. What we see at a glance is that the number of positive cells, so the cells above this cutoff, above the isotype matched negative control, increases from 16.78 to 44.73%. But what we also see is that there is a shift towards higher populations. In normal skin, the maximum value is here around 90, but that increases after UV irradiation to 130. So what we visually perceive as more cells positive is reflected in this percentage value, and what we visually perceive as the cells being stronger positive, this is reflected here by the shift towards higher values. Like in flow cytometry, we get the quadrant statistic. The two cutoffs, this, which is the cutoff for the parameter shown on the x-axis, being the intensity of the DNA staining, and this, which is the cutoff for the parameter shown on the y-axis, which is the marker under investigation. These two cutoffs separate our diagram into four quadrants: the upper left, the upper right, the lower right, and the lower left. UL, UR, LL, and LR. It's the same terminology that is used in flow cytometry. And in this quadrant statistic, we see the mean values for the parameters shown on the x-axis, on the y-axis, the total number of events, the events normalized to the area, so number per square millimeter, and the relative percentage. One of the features that our clients around the world appreciate most is the ability to track back and forth individual cells in the virtual slide and the corresponding dot in data space. So whenever you click a cell in the image in the virtual slide, the corresponding dot starts blinking. So you will know exactly where this cell is located. Here we see DAPI versus green. Here we see DAPI versus red. So if we click on a green cell, it's in the green positive, red negative population. If we click on a red cell, it's in the green negative, red positive population. Green in this case means CD3 and red CD68, so T helper cells and monocytes. Following our motto from image to data, we consider this a step forward, and thus this feature is called the forward connection. It also works the other way around, from data space back to the image. Like in flow cytometry, we can set a gate, which is a selection of a subpopulation of cells, which will also be visualized in other scattergrams, in other dot plots with a specific color. We can click on that gate and show what we call the backward connection or reverse gating. The content of any gate will be shown in the virtual slide with a different color. So all the cells are analyzed, but those cells which are part of a gate, of any specific gate, will be shown like here in red. This way we can visualize where a certain subpopulation of cells is located and get a correlation between phenotype and morphology or histology. Where are those cells located in our tissue sample? Maybe one of the most important applications of TissueFAXS cytometry is the determination of the immune status in situ. With flow cytometry, we can determine the immune status systemically in blood. With TissueFAXS cytometry, we can determine it in a specific organ in a specific tissue. This is also called the phenotypic characterization of tissue infiltrating leukocytes. In this example, which we received from a client at the University of Western Australia, we see a 4-color staining. DAPI, the nuclear marker, in blue, CD4 T helper cells in yellow, CD8 cytotoxic T cells in red, and the marker FOXP3 in green. You may know that the CD4 FOXP3 double positive population is referred to as the Tregs, the regulatory T cells. Using the nuclear marker, here DAPI, as a master channel, we see what the software recognizes as individual nuclei, indicated by the green contours. And then, for each individual cell, we measure how much yellow, how much red, and how much green is present. And of course, this measurement can be extended to any number of cells and any number of channels per cell. Here we see the result for CD4 positive cells. So this is the cutoff for CD4, and this gate highlights our CD4 positive T helper cell population. By using the backward connection, we see where those cells are here in the tissue, indicated by the red contours. The same can be done for CD8, the cytotoxic T cell population, and finally for CD4 FOXP3 double positive cells. So with this software we can identify and quantify co-expression of molecular markers on the single cell level in tissue sections. TissueGnostics image cytometry software consists of 3 applications. HistoQuest, which offers single-cell analysis for tissue cytometry in bright field samples, so immunohistochemistry. TissueQuest, which does the same but in fluorescence. And the high-end application, StrataQuest, which offers contextual tissue cytometry in both bright field and immunofluorescence. In more detail, the analysis packages offered by TissueGnostics allow to analyze TIFF, bitmap, PNG, and JPEG generic image files. They also support BigTIFF and OME TIFF, as well as in general the bioformat standards. The high-end software StrataQuest also allows to incorporate MATLAB algorithms, ImageJ macros, and Python scripts. I hope with this brief introduction I could give you a solid idea of how TissueGnostics products are working, and that TissueFAXS Cytometry platform can indeed contribute to a more robust experimental design. In this publication, a research group from University of Western Australia in Perth has made a comparison between visually counting FOXP3 positive cells and comparing those counts of 3 observers, of which a median was computed, to the results obtained by our StrataQuest software. This comparison shows a correlation coefficient of 0.979. In a nutshell, TissueFAXS Cytometry supports researchers to move from image to data and thereby helps to increase observer independence and reproducibility. If you would like to learn more about our applications, please refer to our webpage and our online video tutorials. I would like to invite you to visit our webpage, tissuegnostics.com, where you will also find a complete list of reference publications. This list is updated every month, and all the papers are in a searchable database. Here you see how breakthrough research powered by TissueFAXS evolved over the years since the company's foundation in 2003 up to the first quarter 2020. I hope with this short introduction I could show you how TissueGnostics and our TissueFAXS Cytometry platform can contribute and support you in exploring the fundamental unit of life, cells in tissue, at the precision that inspires.